Maintenance of irrigation systems is a high priority, as is distribution uniformity. And here to talk a little bit more about that is Jamie Whiteford from Ventura County Resource Conservation District to talk about the services that they offer for growers here.
So as Giovanni indicated, my name is Jamie Whiteford. My title is Irrigation Technician, and I do work for the Ventura County Resource Conservation District, the VCRCD. And I'm going to talk primarily about the Mobile Irrigation Labs. The Mobile Irrigation Labs is simply a program that the Resource Conservation District offers as a service to growers. And also we do get into domestic users of water as well if they have small acreage devoted to some kind of production. I'm also going to take time to just briefly introduce you to the Resource Conservation Districts as an organization, simply because I want to make sure that you're comfortable working with us, and to do that you have to understand what our role is. And then I'm going to introduce some of the other programs that we have, because even though we're here to discuss irrigation management, the Resource Conservation District has other programs that you may very well be interested in. So with that, oh, and before I get any further, thank you, Ben, for that wonderful introduction to the Resource Conservation Districts during your talk. We truly do appreciate that. So the Resource Conservation Districts, or RCDs, we're the Ventura County Resource Conservation District, only because we operate within the boundaries and jurisdictions of Ventura County, hence the name. But there are all kinds of different RCDs. They're local organizations. There's RCDs that are located in Santa Barbara. There's RCDs that are located down in San Diego area. Usually the RCDs are local organizations with distinct boundaries, and those boundaries are defined by county lines or some other distinct geographic feature. There's about 97 or so RCDs in California, and our parent organization is the California RCDs, California Association of RCDs. And so we actually have a big get-together coming on in November, I think it is, here in Ventura. A lot of the RCDs throughout the state are going to be here, and hopefully we'll be able to list some growers for some field tours and all that kind of stuff. Now, these different RCDs have different management structures, and they also have various and different programs. And those programs are developed to fit the local needs, because we are local organizations. Our whole mandate is to help local growers assist the organizations in that boundary area in whatever kind of conservation programs are needed for that particular region. So the Ventura County Resource Conservation District, or VCRCD, covers Ventura County. The one thing that I want to make sure that you understand, you'll hear this through other organizations as well, is that the Resource Conservation District, VCRCD, the organization that I'm here representing, is non-regulatory. We cannot tell you what to do. All we can do is assist you in implementing things that you think will address other people's concerns from a regulatory standpoint. Or if you have concerns from resource management or some kind of other a resource issue, then we can help you through either technical assistance or hopefully some financial assistance. So despite the name, we are not a county government entity. Okay? We are organized through local, as a local agency formation, something or another. So from that standpoint, we're like quasi-government, but we're not on the county payroll, state payroll, or federal payroll. We're actually nonprofit, and we're primarily funded through grants. We have almost no base income from any source other than grants. So we have to apply for grants to help growers do what they need to do to conserve water, conserve resources, and that's where our salary comes from. The programs that we do have are all a function of funding. So what do we think the county needs? Do we win competitive grant funding to implement that program? If so, then that's the program that we work in developing and work with growers to address issues that are facing the county. So we have various issues that I'm going to talk about very briefly. Stormwater quality program addresses water quality concerns primarily through mitigating the impacts of manure and thereby nutrients getting into surface water quality bodies. And my colleague Caitlin Teague is one of the people that works diligently on that particular program, as well as assisting me and my boss in the mobile irrigation lab. We also have the programmatic permit program, trying to address invasive weeds getting into our watersheds, particularly tamarix and arundo, which have huge transpiration rates, lead to issues with debris fields causing damage to infrastructures, changing channel flows, all that kind of stuff. And then what I'm really here to talk about, the MIL, or the Mobile Irrigation Lab. And we primarily work on water conservation, although depending on the emphasis of the granting agencies that's giving us funding so that we can actually provide this service, we may also dabble a little bit in nutrient management and nutrient resources. So I'm going to move into the MILs, the Mobile Irrigation Labs. So the MILs are managed by Area Resource Conservation Districts, or RCDs. In the case of VCRCD, our mobile lab started in like 2007. So we've been doing this service for quite some time. The grant is funded currently by the California Department of Water Resources. Last year, the program was funded by the state resources, the Water Quality Resources Board out of Los Angeles, but this year we're getting funding through the DWR. Now, our particular program is free for agricultural producers. That is, if you grow an acre or more of production within Ventura County, again, within that boundary that I talked about. We also have a fee for service for non-ag, so domestic users can have us come out and check their irrigation system, but we do have to charge a fee for that because our grant won't pay for us to do domestic users, except for the case of Casitas Municipal Water District, because Casitas Municipal Water District and the Resource Conservation District have entered into an agreement. They'll actually pay for us to go out and do irrigation evaluations for domestic users. So what happens is the Ventura County Resource Conservation District Mobile Irrigation Lab staff, including myself, Caitlin sometimes, and Vic Akunzadeh, the supervisor for the MIL program, will come out and provide irrigation system evaluation. So, you know, I put these pictures in to remind me to emphasize, we do row crops, we do orchards. This is the Mobile Irrigation Lab. This is our truck. We have all of our equipment here. We'll drive right up into the orchard. In this case, it's the mixed lemon avocado orchard. From there, we'll go out and we'll actually do our sampling within the orchard, within particular irrigation blocks. But in addition to row crops and orchards, we also do nurseries. So we'll go out and evaluate the pressure and the water flow characteristics under that system as well. All right, so an irrigation system evaluation. What is entailed by that particular process? Well, what we'll do, the staff will go out and collect random sampling of flow and pressure measurements. So we'll go into an irrigation block, and we'll just randomly collect water samples to determine what the flow is from that particular emitter. So here's Caitlin, actually, with Vic out, and she's got a graduated cylinder there that she has collected water over a set period of time. That gives us the flow. Now, all of our emitters are rated at some gallonage per hour. All right, so we're going to basically get that gallonage per hour, okay? And we're going to go through the whole orchard at various randomly assigned emitters and make sure that that flow is actually the same. If it's not the same, then you're going to have inefficiencies. You're going to have ineffective distribution of your water. All right, so we assess the system's distribution uniformity. We have very specific value that we're looking, that we're deriving. It's called the low quarter distribution uniformity value, or DULQ. That's gotten from putting in all the data that we collected into a spreadsheet. It spits out a comparison of what your low quarter, the lowest population of numbers or flows that you're putting out, versus the average for the whole population. That's why it's called the DULQ. But this number is exactly the same as what Ben alluded to earlier, the DU value that shows the uniformity of your water distribution. So from this assessment, we can determine ways to improve your DU value. We'll provide the grower a report that has all the data that we collected, as well as recommendations that are designed to address those inefficiencies and correct them. And then we also have a program that provides incentives for improvements. And that's probably one of the more important considerations that we can talk about today. Everybody wants to improve their distribution uniformity, I'm sure, but how are you going to pay for it? The Resource Conservation District has a program to help you with that. So this is basically a DU report that you'll get, just like here. It includes all these data pages, and it also includes some information. For example, this one has a little flyer put out by Extension Center about Phytophthora, the dangers of overwatering. There's oftentimes a soil map, so you have an idea of what kind of different textures you have, what their differences in water holding capacity is throughout your orchard. There's a GPS map, so you can orient yourself with respect to where the data was collected. And then, of course, there's just data and recommendations there for you to look at as well. And all of this, you have a chance to read it over, look it over, and then you would call us if you have any questions or if you want to move forward with implementing some of the recommendations that we provided. All right, so irrigation system evaluation. I just want to sort of dwell on this DU value a little bit. So DU just stands for distribution uniformity. So distribution of water, uniformity meaning how evenly is it applied. So DU value is just how well your irrigation system is applying the water that you're sending through it. The specific DU value that we look for is the DULQ. And again, the DULQ is just a comparison of the lowest outputs to the average of all of the outputs. And this is a program, and this particular assessment was developed at Cal Poly's Irrigation Training and Research Center at SLO. Again, it requires that we measure flows. So we'll go out, just like the earlier picture showed, and we'll collect flows from a random sampling of your emitters throughout the orchard. We'll also measure pressures. So we go out there with a pitted tube and a pressure gauge, and we measure pressures at the ends of the laterals and at the risers, again, randomly throughout your orchard. And again, as I indicated, the DULQ is a specific value. It can be thought of as a percent, but it's really just a ratio of that lowest quartile population to the entire population average. And what it's telling you is the water evenly applied or not? The higher your value is, acceptable range for micro sprinklers would be 0.85. Okay? So as Ben stated earlier, that means that what you're seeing is 7.5% of your trees are underwatered, 7.5% are overwatered, and so that's going to lead to problems. And then one of the things that's critical to everyone is how much extra water is having to be applied to water everything in your orchard. Because oftentimes what happens is people water to the trees that are receiving the least amount of water. But at the same time, as they're addressing that problem, they're creating overwatering problems with the trees that are already getting enough water. And then you have that huge population in the middle that's already doing fine. But now, when you apply more water, you start moving them over into that population that's already overwatered. Okay, so you start creating a lot of problems when you have low DU values. And you can see DU values range from excellent to unacceptable. I'd like to point out this DU 59%. There was a question about furrow irrigation. Furrow irrigation has been around forever. Okay? If done properly, you can get acceptable DU values in the sense that you can get 60%, and that's in the range of a poorly maintained sprinkler irrigation system. So you could have an excellent furrow irrigation system that's actually more efficiently applying your water compared to somebody who has a really poorly maintained irrigation system. Okay, so just keep that in mind. So to visualize DU values, this would be an orchard that has a poor distribution uniformity because, probably because of pressure issues, these trees up here are getting far too less water, and these trees down here are getting far too much water. So you're going to get poor productivity here, and you're going to start with declining health of your trees here, which is ultimately going to impact your productivity throughout the entire orchard. But with respect to what it can do for us, when you have an irrigation system evaluation done, it potentially saves water and money, and of course you pay for your water, so you save potentially lots of money. Low DU means some water is wasted, and actually I would say, and this goes back to what my supervisor Vic always says, you know, if you're applying just enough water to keep your trees growing and there's no productivity, then you really are wasting water. Because what are you using that water for? You're just keeping a tree alive. So, you know, just applying enough sometimes isn't good enough. Sometimes you do need to apply more than what you may think to get the productivity up. But you have to have measures in place to make sure you're not wasting it. Because for us, water use efficiency is more important than saving water. If you're going to use the water, you're going to use the water anyway. You might as well use it well so you get something out of it. But basically, when you have a low DU, it means that you're wasting more water than you need to, and you need to address that low DU by implementing some kind of management practice that's going to raise that DU so that all the water you are applying, even if it's more than what you used to, at least all of it's being used the way it's intended to. So your water use efficiency goes up. So what a low DU means is that you need more water to properly irrigate all the trees in the grove, because you're going to be looking at these trees saying, oh, they're yellow, I need to water more. You're going to water them for an extra 2 hours, 3 hours, and you're going to end up drowning all these trees down here. When you apply too much water, though, it means that there's more water needed for fertilizer as well. So you're going to have to put in more fertilizer because you're applying more gallons per hour. You're also going to run the risk of having more leaching below the surface that can get into surface waterways, carrying those nutrients with it. You can also have direct surface runoff that everyone can see, and that'll get you in a ton of trouble. And then more water tends to mean that you have soils that are anaerobic and allow Phytophthora, which is always there, but under those conditions, they're selected for. So everything else dies off, leaves the whole niche open for Phytophthora, and their populations go crazy, and they end up infecting the tree. One of the other things that we provide is a nutrient analysis of your irrigation supply. I think Ben alluded to this earlier. There are some cases where you're getting enough nitrate through your well water source that you don't even need to add any fertilizer. Okay? You're getting all that you need every time you irrigate. So we provide this as a service so you have the ability to tell your crop advisor, hey, I've got this amount of nitrate in my water already, so back that out of how much I should inject. But do keep in mind that these levels can fluctuate as a function of your water quality. So if you get more freshwater inputs through rain, hopefully, then your nitrate levels should be diluted to a lower state. So again, always get your water quality checked several times. Okay? All right, so what happens with low DU in avocados? Well, here's Vic. This is water being applied to keep the tree alive. There's going to be no productivity here. Here's an avocado tree being properly irrigated, same age. This tree is much larger, more productive. These trees are probably getting more water, but at least there's going to be some productivity out of it. Okay, so these trees getting very different types of water, and it's having a direct impact on the tree and its productivity. You can see that these trees are suffering, very yellow, low amount of nutrients getting into the tree because there's just not enough water movement to carry those soluble nutrients with it, so the tree is starving both of water as well as nutrients. So here's just a graph that sort of indicates the difference between the water that you're applying being useful and not being useful. So if you're applying a gross amount, 4.5 acre feet, or in this case, I'm sorry, it's waters in inches applied, so 4.5 inches worth of water being applied. Here you have average of the water that's actually that's infiltrating into the soil. This is just pre-infiltration loss, so what actually leaked out of the spaghetti hose before it even got to the emitter, or was lost to aerosol because of overpressurized system. And then what you're getting is about half of that is beneficial. This is for a low initial DU. Now for an improved DU, again, same thing, pre-infiltration losses are, and this is the same amount of water, pre-infiltration losses are all, usually pretty low. Average get into the soil, the difference here. But because of the increase in the distribution uniformity, you're not having selective plumes of water being lost in certain areas of your orchard versus other areas that are getting almost no water. It's all being evenly distributed, so all the trees are getting the amount of water that they actually need and they'll actually be able to use. So one of the things that comes in this report following the assessment of the irrigation system and the calculation for the DU value are recommendations for irrigation system improvements. As was discussed earlier, pressure is a big issue here because we grow, as many avocado growers do, we grow on slopes. And so because of gravity, we have higher pressures down at the toe slopes compared to what we have up higher on the slopes. So you need to have some way of regulating that pressure. And there's two ways of regulating pressure. Or I should say there's two separate populations of pressure that we're concerned with when we do irrigation evaluations. The first is the pressure that's in your submain. So maybe your 2-inch line, 3-inch line that's running up the slope, buried. And then you have risers that come up out of the ground. Okay? There's pressure within that submain. And obviously, you're trying to pump that uphill, so there's going to be less pressure up top, and there's going to be higher pressure down below just because of that weight of pressure pushing down, creating pressure down at the toe. That's one source of pressure problems. The other source of pressure problems is when that riser comes up, it feeds into a T that feeds off into laterals, these 3/4 or 1/2-inch poly hose. All right, well, if those are all evenly spaced along the contours, then maybe you won't have a pressure issue. But if you have your laterals running at a slope, then you're going to have pressure issue at this end because it's lower pressure than this one here. All the water is going to come out that riser, and it's going to want to follow gravity. So you have pressures within your submain you have to be careful about, and you have pressures on your laterals that you have to be careful about as well. So that's the reason that we'll often ask people to consider pressure regulators, because pressure regulators like this regulate the pressure coming into the riser. So they maintain a better pressure distribution within that submain. All right? Now, once they get out of that riser, past that 20 psi regulator or 25, whatever it is you have in place, then they're going to flow in the laterals. But again, if you have an issue like this, how do you regulate the pressure once the water gets in those laterals? Well, you do that by having pressure compensating emitters. So the Toros or the Netafems or fan jets, whatever, usually there's a contraption you can add to it or it comes as part of it that regulates the pressure at the emitter itself. Okay? And certainly you can have both of these measures in place to protect and maintain your pressure in the submain as well as the pressure throughout your laterals across your entire orchard. And as Ben also mentioned, please always consider breaking up your irrigation blocks to address issues that are specific for an area so that you have better control. Also, use the appropriate sprinkler. Make sure it's the correct volume. You don't need a 14 gallon per hour emitter on a tree you just planted. Put in a drip emitter. If you have windy areas, the fan jets are usually not recommended in really windy areas because they put out smaller droplets and they just fly away. So they're not getting into the soil like they're supposed to. Also, the pattern of the sprinkler. First of all, we talked about salinity issues. Well, most of the avocado roots, the new roots, the ones that are active in nutrient and water uptake, are going to be located around the drip line of the tree and the canopy area. So those are areas you certainly don't want to get highly saline because that's going to burn those new roots. You want to make sure that that area where the new roots are growing around the canopy is going to stay well hydrated so that the salts have a chance to be diluted away and perhaps even leached down. Keep the spray pattern off the trunk. Those are old roots anyway, right by the trunk. They're not going to be that active in uptake of anything. You're going to have a nice plume field underneath as all that water drains away. And they're just going to lead to fungal issues with that trunk being perpetually wet. All right? And also at the end of the laterals, you don't need to be spraying water into your access road. Have a particular pattern that sprays it back into underneath the canopy. All right? Yes?
What's the typical life of a pressure regulator?
Oh, a regulator? We see them in the field 15, 20 years still working. Just because, thank you for that question. Just because your system is old doesn't mean it doesn't work very, very well, okay? It could work very well. This is all hardware. And so it can last forever. They're all UV treated, so you don't have to worry about them breaking down. Usually the biggest problem we find is they've just been nibbled so much and goof plugged so much that you've got just tons of leaks that you don't even really are aware of. So just because it's old doesn't mean it needs to be replaced, but if you are seeing issues with respect to watering patterns, then you should have it checked. Does that answer your question?
How do you check the pressure on those? Just with a regular gauge? Or?
Yeah. You can go to Fruit Grower Supply or just about anywhere. But if you want to buy a pressure regulator to do the system check yourself, if you want to buy a pressure gauge, get the oil-filled pressure gauge because they're not so prone to jerk as the pressure varies. And you just need we use a little pitted tube, and it's just a narrow brass cylinder, screws onto the end, and we can actually use that to go right into the lateral itself. Right by the riser if we're checking riser pressures, or at the ends of the laterals if we're checking ends of the lines. But yes, you can pick those up. They're not too expensive.
What type of filtration do you need for those compensating?
It varies by the manufacturer. So there's all kinds of different pressure compensating emitters that you can buy on the market. Netafim makes them. The fan jet types are actually a separate unit. They're a round diaphragm that you cut your spaghetti hose, you put that in, it's got two barbs on the ends, and that regulates the pressure, so you can use your existing fan jet. But the idea behind the pressure compensating emitters is that they'll maintain a steady flow even as the pressure varies. And so it's going to be different for whatever emitter that you put in place.
It won't be don't be required a different mesh filtration?
For the emitter versus the...
Compensating?
Yeah, you have to get the right, usually they're color coded.
Right.
So for example, if you have purple fan jets, you want to make sure you get a purple diaphragm.
Yeah. I just want to make sure that.
Yeah. Yeah. Oh, thanks. Yes. Good point. Yes, sir. Giovanni.
I don't know if this question's better for you or for Ben, but what role does evaporation during an irrigation play in water loss, and how much better may it be or not be to irrigate at night versus during the day?
Well, for avocados, you're always going to find mulch, I should hope. So really, I think the bigger problem is overpressurized systems that aerosol the flow, because that's a huge loss of water, because you're producing very, very fine droplets of water that are easily evaporated by ambient temperatures. The water that's in droplet size that splashes and gets into the mulch and begins infiltration, once it's disconnected from direct solar radiation and from the increased evaporation rate just because of turbulent flow of air over the mulch surface, it's not going to evaporate away. It's going to infiltrate into the soil. And this is a characteristic of soils. They actually self-mulch. Everybody has, looked at their soil, it's dry, you take a probe, you dig in it, a fraction of an inch in, it's moist again. It self-mulches. The soil surface sort of seals off because all the water evaporates from the surface. But once you evaporate that water in the soil, it's gone away. It's not going to pull up any more water from the soil depth. So it basically seals off. So I would say that surface evaporation, not as much of an issue as overpressurizing and aerosoling, and now you really are losing a significant amount. How much that is, it would be total guess. Ben?
Yeah. If you look at all the reports that come out from cities and water departments, they say, don't irrigate during the day, irrigate at night, because evaporative loss is less. And I've never seen any study that shows that. The thing is, when you irrigate during the day, you raise the humidity, lowers the temperature, and transpiration loss is less. So the trees lose less water. At night, you can irrigate, and it does the same thing. It lowers the temperature, it raises the humidity. There's not a whole lot of transpiration going on, so there's not going to be a lot of evaporation going on at night either. And the problem with irrigating at night is it's hard to see the leaks. It's hard to see where the coyotes are. So it becomes just a management issue. Yeah. So I have never, ever seen any data that shows more water use during the day than at night. Now, that's for an orchard. Now, maybe true for a landscape where you've got wind blowing over the lawn and it's getting carried off the property. But in an orchard, there's not a whole lot of wind. You go into it and boom, it's not windy any longer. And wind and solar radiation are the two main driving forces. And number 3 is humidity. And so all of those, there's no sun in an avocado orchard, there's no wind in an avocado orchard, and the humidity's high when you irrigate. So I don't think it pans out. So.
Yeah, I agree. I don't think it pencils. It makes total sense. Don't irrigate when the sun is up, but with all the other factors, it just doesn't pencil, particularly the leak. And I'll just step aside for one moment and tell this story because I just have to. I live next to a barranca. The city irrigates that barranca grass because it's actually green space. Well, they turn the irrigation system on at like 4 o'clock in the morning. I know because I hear it, I'm up. There's a leak. It's spewing 6 foot high in the air. We call and say, I'm sorry, but you've got a geyser. And they say, oh, I'll tell the guys when they get in at 9. Okay, so it's going to run for 3 hours before someone even gets around to maybe shutting it off. But they saved a ton of water because they didn't irrigate during the day. So anyway, yeah, I have a problem with that. And now I'll step back into my RCD shoes. And I also want to point this out, again, this is a graphic showing just a change in elevation that we have within a lot of our avocado groves. And also I want to point out that change in elevation has distinct impacts on the microclimates that those those trees experience, whether it's just change in elevation and temperature, humidity factors because of the movement of the marine layers, or wind, or just the way it's facing towards the sun, whether it's north, south, or some other direction, because all that has an impact on daily evapotranspiration rates, evaporation rates themselves, et cetera. Always, we recommend that if you are going to do anything with your irrigation design, make sure you get a professional to help you with that. So Fruit Growers Supply has an irrigation design team, so does Coastal Water Solutions, and just about everybody has somebody on staff who can help you design a system to meet your requirements and address issues related to topographic changes, your pump size, all that stuff. Because now there's software that's available for them to be able to do that adequately. Before, they may not have had access to those resources, and most of us probably don't either. So please, it's usually a free service. They just ask that you buy your stuff from them if they do that service for you. But get somebody to look at it who's a professional. Main and submain layout, pump and pump pipe size. Again, make sure you're checking that. You should have the right size pump for the amount of water that you need. You should have the right pipe size so that you're conveying enough water to where it needs to get and have adequate pressure at its final destination. Lateral lengths. If you have too long of a lateral, and too narrow of a lateral, you end up getting frictional loss. This is just water that it's sort of adhered to the surface of the lateral, and it's just not going to contribute to the overall flow. So don't run them too long. You'll peter out of water before you get to the end, and that tree won't get enough water. The poly diameter, again, this is all a function, everything together, and that's why you need to have somebody who can do these head pressure measurements and can do all of these frictional loss measurements there with the software that they have available to do exactly that work on your behalf to design the system. Again, please get a pro, at least just consult with them. Even if you want to do the work yourself, at least have some kind of plan that they've helped you develop. Irrigation monitoring, timers, we all have irrigators who go out and check everything. Sometimes they forget, and your irrigation system runs for an extra hour, 2 hours, they get sidetracked. It's running longer than it needs to. So timers that help regulate that, always good. Flow meters, so you know how much water you're applying, is always good. And this is important, particularly if you are interested in cost sharing with somebody or getting financing from someone to help you with irrigation system improvements, because generally speaking, they need to show efficacy. They need to demonstrate that the money they gave you actually led to some improvement. And generally, it's tied to water use reduction. Meters are going to be about the best way for you to actually tell them how much water you're using, and therefore how much water you're saving compared to historical water use records. Irrigation monitoring is also important. Tools are sensors and probes. So sensors are going to be the solid state sensors that you put in the ground, actually monitor what your soil moisture levels are. And then probes are going to be those tools that you use, like a shovel or just a soil probe, to see what the moisture levels are down within the soil itself. So this is a paired fan jet with a pressure compensator. Okay, so this would be a pressure compensating emitter. You can buy them separately. You can just have a fan jet, but here you have the diaphragm that regulates the pressure at that emitter so that it's within its normal operating pressure range. Here's a riser, no regulator, it's just a bib. Okay, there's no way to determine what that pressure is or to control it. And then here's a Hortow system, actually a solar system that powers soil moisture sensors that are buried in the ground. And there's probably also a weather station there, so you know your local relative humidity, solar insolation levels, et cetera. So recommendations for irrigation scheduling. There's all kinds of irrigation scheduling tools, weather-based, soil moisture-based, Tzimmes, California Irrigation Management Information System, Atmometers are on-site sensors that tell you what your local evapotranspiration rates are. Others, just anything that you can use that's going to give you a better idea of what's going on weather-wise and on your ranch is useful, okay? Because it helps ground truth information you may be getting that's more regional, and information you may be getting from someone who doesn't really know anything about your local area. Soil moisture-based probe or a shovel, again, just so you can see what that moisture level is. Some cases, get your hands on that soil and feel how much moisture is there. Soil moisture sensor systems, these would be things that would go in the ground that allow you to actually determine what's going on, usually in real time or 2-hour lag real time, within that root zone, which is really what you're interested in. Feel method, anything that you can do to monitor the soil moisture in your orchard. This is an irrigation calculation, and I put this in here only because I wanted to point out that this down here is where you put in your uniformity value, okay? And the way that's used is you know how much water you're probably going to need to apply over the whole year. You break it up according to what your irrigation schedule allows, and then you come up with a gallonage that you need to apply every time you turn your irrigation system on. You also know how long you need to run that system. But that value is, the DU value is used to sort of bump up that amount of water that you know you need to incorporate your loss by your system due to inefficient application, okay? So it has a direct impact on your irrigation calculation if you do irrigation scheduling, or if you have somebody do your irrigation scheduling for you. So improving that value gets you closer to applying the absolute amount that the tree actually needs, okay? So weather-based Tzimmes, be aware Tzimmes is just a standardized way of telling you how much water was lost, okay, due to weather. So there's standardized weather stations. They're located all throughout the area and beyond. What they provide is data for ETO, evapotranspiration, and keep in mind that it's by zone, okay? So you have all these stations spread out, but what they're really doing is giving you a measure over these geographic ETO zones, all right? So if you have microclimate conditions, the regional values you're getting for your evapotranspiration zone may not give you a really good value for irrigation purposes. You also have to have a crop coefficient, and this is going to vary based on the phenology of your trees, if you're in fruiting, if you're in flowering. Needs active management, so the data you're getting, you've got to know what your soil texture is, you've got to know what direction your orchard is, the aspect, whether it's getting southerly solar insolation levels or northerly. You also have to have best management practices that you already have in place, like mulch, for example, so that you know how much this translates into active irrigation application. Another weather-based tool is atmometers. These are on site. They measure evaporation. You can put a little cloth filter on the top that kind of replicates your loss from your type of crop. So these provide you a direct measure of actual evaporation of water. So you know how many inches you need to reapply just because the sun was shining, the wind was blowing, okay? We also recommend different types of soil moisture sensors. Tensiometers, for example, great tools. They just need to be maintained. A lot of people, I don't think, realize that, so they just sort of let them fall apart. But they are great tools if you maintain them, and there's a lot of orchards that still have them in place. Tensiometers give you a direct measure of soil tension. That is, what's the struggle going on between the soil and the tree, or whatever it is you're growing. You want to make sure that you have enough water in that soil so that the tree, or whatever it is growing, doesn't lose the battle, okay? Because the soil itself will hold on to water very tenaciously. And the more stuff that's in the soil to hold on to that water, the more difficult it will be for the crop to get that water. The crop has to expend energy to get that water out. So the more difficulty it has, the more energy it has to expend, and the less it's going to be able to fruit and produce the return that you need. Moving to the 21st century, because of the issues related to tensiometer maintenance, we're moving more towards recommending the soil moisture sensors. You've probably heard of the gypsum block sensors. The problem with the gypsum block sensors is that they do dissolve over time, and they're not buffered well against salinity problems. So you'll get a higher reading than you would just as they age. The new generation, kind of the same principles involved, but they use very low solubility, very high solubility material as a granular matrix, and that acts as a buffer for soil salinity. So there's not a response due to soil salinity when you're actually getting your tension readings using these new generations of sensors. Generally with these, we ask you to put in two, one above the root zone, in avocados about 12 inches, and then one below the root zone, say 24 inches. The idea is that when you wet your soil through irrigation, you'll get a response from that top sensor telling you, okay, water is infiltrating. And then when the watering front gets down to that lower sensor at 24 inches, it tells you, okay, the wetting front has reached below the root zone. Now you can turn off the water. So now you know how long you need to run that irrigation set, okay, to minimize below root leaching, unless you actually need to leach for some reason. The most important thing is when you put in these, we always say, please just follow normal practices so that you can get a trend and then adjust your response to what that trend is telling you. If you used to irrigate for 10 hours and it takes 8 hours for that wetting front to reach the bottom one, then slowly adjust your irrigation to go down to 8 hours instead of 10. Okay? It'll also tell you what the tension is in the soil. So if you are low enough tension, the tree is able to get plenty enough water, then you don't need to irrigate. But then when your tension starts to get to high enough levels where the tree is struggling and having to expend too much energy to get that water, then you need to turn your irrigation on. So that then gives you your frequency, okay? The first set of data tells you how long to run it, and then that second set of data tells you how often you should run it. 14 days versus 10 days versus 7 days. All right, so how many? That's one of the biggest questions people have. My response is always, you need at least one station that has two of these above and below the root zone. But wherever you have changes in soil texture, you need a pair there, a station there, okay? If you've got a high productivity zone and a low productivity zone, put one in the high productivity zone so you know what you're doing right. Put one in the low productivity zone so you know what you're doing wrong, okay? So the more of these soil textural changes you have, the more different slopes with different aspects you have, put them there. They're not terribly expensive, and you'll reap the rewards of just saving water, nutrients, and everything else through time. All kinds of different soil sensors. These are the aerometer kinds that are associated with, these are actually digital tensiometers. They're just these that have wire leads so you can get a digital reading from them more convenient. These are also digital. This is one that's produced by PureSense. They put them out in the field. And then I think this is a dielectric here. Just pulses a current through it. It just gives you the same kind of information. So as far as soil moisture based, if you don't want to put in one of those systems, then what else can you do to monitor what's going on with your soil? Well, the same thing we've done forever. Is it easy to penetrate? Take your penetration tool out there. If it goes in easy, then it's wet. If it goes in, if it's tough to get in, then it's dry. And usually you can feel how deep down the watering front is just by that change in penetration strength. The look of it, it's darker, it's usually going to be wetter. Color, things like that we use all the time. Feel method. Feel method is when you actually can take that soil and sort of feel how much moisture is there. It's related to soil texture. The behavior of the soil is going to be a function of what texture it is. If it's a clay, it's not going to behave the same as a sand, and neither of those are going to behave the same as some kind of a loam that goes between clay and sandy. Practice and persistence. If you've been doing this for a long time, you'll usually get the hang of it, and you can use it very, very accurately. But if you don't have the patience or persistence, or if you just want to sort of get some basic information about your soil texture, then please make sure that you're aware of the Web Soil Survey. It's an online tool produced by the Natural Resource Conservation Service, an organization that we're constantly confused with, but we're not the same organization. NRCS is associated with the USDA, so they're associated with the national government. But they produce a lot of great services, and one of them is this Web Soil Survey. You can go on and you can pick out your area of interest, your ranch, for example. You can have a little box that covers your whole acreage. You can then get all the information related to the different types of soils that you have in your area. And then, of course, you or your ranch manager can go out and ground truth that, verify that on the ground through the field method or some other technique. Now, I'm going to get into the money part of it because this is really important for everybody here. We can actually provide incentives to help you implement some of these improvements. So the Ventura County Resource Conservation District has an incentives program. Again, our funding is through the Department of Water Resources, and the particular iteration of this grant is the Agricultural Water Use Efficiency grant. So we can offer some cost share to implement improvements through this grant. You have to maintain water use records because you have to demonstrate that you're actually putting in practices that will reduce your water consumption. You need to submit receipts for all the work that you did. It covers hardware, so like pressure regulators, pressure compensating emitters, soil moisture sensor systems. We can help pay for that. So it only covers hardware. It covers 60% of your reimbursable costs. That would be the hardware stuff. We can't cover costs related to labor, fees, taxes. Those you have to pay yourself. But we can cover 60% of how much this costs, how much that costs, how much that costs. There's a cap, 20,000 ceiling for the specific location. We also have to charge a one-time fee as part of your cost share component. It is a cost share. So you have to pay for part of the program where we come back and we reevaluate the incentives that you implement the improvements that you put in place. Okay, so you'll pay $995 if the amount of money we get back for you is greater than $7,500. If it's lower than $7,500, then it's either going to be 10% of how much you get back, or a lower ceiling of lower floor of $375. Okay, so the fee you'll pay will either range from $375 up to $750, or it'll be $995, depending on how much money you're actually getting back from the Department of Water Resources for the improvements you put in place. All right, I want to point out the Natural Resource Conservation Service, again, NRCS, Web Soil Survey, the one that we always get confused with. They also have financing available. They used to be located in our office in Tzimmes, but they moved out. So now they're down in Oxnard. Dawn Athman is the district conservationist. You can call her at this new number. Here's her extension. You can also visit her on the web, and here's her email. But they have equip. They also have money available for water storage, on-site water storage, and they do conservation planning. I want to point out that Casitas Municipal Water District, one of our partners for doing both domestic as well as ag production, is available. They have their own cost share program. They have two different programs. There's the ag producer program, and then there's the hobby farm program. The difference is just the acreage involved. This is actually a screenshot off their YouTube channel where we're out in the field doing an evaluation. So you should check that out if you're interested. Here's her contact information. Municipal Water District also has their Be Water Wise program. It used to be that they would partner with us, but they've migrated everything online. So you have to go to that website to be able to access that funding opportunity. And then there could be others. I don't know, maybe you know of others. that I don't. So check with your local water districts, see if they have any financial help for you. All right, I just want to point out that there's other programs that we're pursuing. There's this regional partnership. We're looking to try to get California drought money to implement other improvements, continue the incentives program. We're working in partnership with the Watershed Protection District, Fox Canyon, et cetera. Water use records are critical, so make sure if you want to get funding for putting in these improvements, you have to be able to tell us what your water use records are. Okay, so if you don't already have one, you should be putting in flow meters so you can track that water use. It's good information for yourself as well. We're also looking at climate ready, and the only reason I bring this up is because I'm writing a grant currently looking to try to reduce carbon dioxide emissions by replacing old direct drive water pumps with variable frequency drive pumps. Those will match their energy consumption and water production with what you actually need so that you're not overrunning your pump just to provide water to keep up head pressure for water that you're not really going to need or use. So this is a potential for funding in the future, but both of these are up in the air. What we do know is that we have incentives now through DWR. Here's my contact information. Again, Ventura County Resource Conservation District is my organization. I'm Jamie. This is my number. Here's my email. I encourage you to go to our website, because on our website you can, on the irrigation portion of the website, you can find a brief flyer about our cost share program, and you can also look over the application for the program as well, so you know what you're kind of getting into ahead of time. And I encourage you, please, to give me a call and talk with me about it, or Caitlin, or any number of staff. We'd love to hear from you. And here we are. Here's our office here in Tzimmes. So we're just a quarter mile down the road on Lewis, right at the 118 intersection. So always welcome to stop by there and check in with us. And with that, I think I've gone on forever.
Quick question. Walk us through, we call and say, yeah, we'd like to have that service, come out and do it. Describe the lead time, what goes on. We're going to have to be turning blocks on and off and so forth during that period of time. How long does it take, and just a quick overview of what that does?
The irrigation evaluation itself usually takes about 4 hours. Okay? So what will happen is you'll call, and generally if you call me, I'm going to pass you on to Vic, my supervisor, because he's the one who does all the scheduling. So he's going to schedule you for an evaluation depending on what we've got going on. It could be in a week, it could be in 2 weeks, it could be in a month. As irrigation system starts to, as irrigation season starts to ramp up, it gets more difficult to schedule. But it usually doesn't take that long at all. We work with you according to what your irrigation schedule is, so if you only irrigate on Tuesday, we'll be there on Tuesday. When we get on site, we're going to have you fill out an application that says we're actually legally allowed to be there, otherwise we're trespassing. So that takes a few minutes of your time to do that. It's a very short application. From that point forward, we just proceed into the irrigation blocks. We don't necessarily have to do every single irrigation block within an orchard. What we do have to do is we have to get irrigation flow measurements and pressure measurements from proxy blocks. So just like you would put a tensiometer in, or you put a weather station in, and a representative block, we're going to want to measure that representative block. We're going to want to measure a representative block. We're also going to want to measure, generally speaking, your most unproductive block, or the one that you have the most trouble with because you have pressure problems, or you have some kind of irrigation-related problem. So that means we may get the job done in a day, 4 hours, or we may have to come back and do another block. Again, should only take 4 hours or so. Once you fill out the application for us to be there, we don't need a second one. When we're done with the evaluation in 4 or 5 hours, we proceed off the property, let you know that we're leaving. From that point forward, it takes about a month to get all the data entered in and get it assessed and produce a report, this thing that I just showed you guys. And then that will be mailed out to you. Once you get that report, you can look through, see what the DU value is, see what the recommendations are. We encourage you to call us to talk about the report. Once you get this report, I'll usually call you within about 2 weeks or so to see if you're interested in the cost share program. Because when this gets sent out, it gets sent out via certified mail. So I get a receipt about when it got sent, and I also get a receipt saying you got it. So I know you got it because you signed for it. Did you look at it? No. Okay, well, I'll call you back in a week. If you are interested in the cost share program now, you step into my arena, so that's a whole kettle of fish. You have a separate application for that, because the irrigation evaluation part of it is sort of just the front part of the cost share program. But the data from the cost share program, from the irrigation evaluation, feeds right into the cost share part of it. So there's a separate application just because you have to recognize that you have to pay a fee and that you're responsible for getting us water use records and stuff like that. That application is 2 pages. Then you have to submit a work plan that says, okay, this is what I'm going to do. And you have to justify it. You know, why are you going to do this? It's not just an academic exercise. You're actually going to save how much water or how much whatever. And once we get that work plan, we look it over, we discuss it, we send you a letter saying, okay, everything sounds good, the numbers pencil, and so proceed. And then you do the project. However long it takes is however long it takes. When the project is done, you let us know it's done. Meanwhile, you're communicating with me anyways. And you're sending me invoices as they come in. And I've got you in a spreadsheet and blah, blah, blah. Once that project is finished, we come back out. We evaluate that improvements. We do another evaluation to see what that DU value change is. And that's important because we can use that DU value improvement to come up with a potential water savings. I mean, if you went from a 0.5 DU to a 0.85 DU, well, now you're having a much better distribution uniformity, and that means you don't have to run your irrigation system as long. Because you're going to see those yellow trees start to improve, and you're going to realize, hey, I can go from 14 hours to 10 hours or whatever. But again, those other tools, like the soil moisture sensors, are critical in allowing you to sort of recapture that water and use it more efficiently, along with the improved hardware distribution. Now, once that project is done, once we've reevaluated the irrigation system, again, that's another 4 hours. That's it. Then we collect all the information, we send it off to DWR and say, okay, this is what they did, this is how much it cost. Now it gets hairy because we're talking about a state agency. They don't like to pay out very quickly. So from that point forward, kind of in limbo. You know, it could be 6 months before you get your money, it could be 8 months, it could be 3 months. But we always advise our clients, be aware, it could be 12 months before, you know, the state send us your money to give to you, okay? So there you go. It could be a year and 6 months maybe, start to finish. The irrigation evaluation, however, is pretty quick, 4 hours. But the whole thing, it can, you know, take time. But once you're in the system and once we send off your invoices and all that stuff, I mean, you're going to get your money. It's just a matter of when. Yes, sir?
Why can't you use your electric meter reading rather than having to put a flow meter on?
You can. If you've got Steve Villegas or somebody out from Southern California Edison to do an efficiency test for you. And when that was done, I don't know, last year, 3 years ago. You can use that as a proxy for how much you're pumping, but just be aware that, you know, if you're running a pump and it's over 150 acres and we only did an irrigation evaluation on a small fraction of it, it's going to be difficult to tease apart the improvement for just that section you did. If you do the whole orchard, then all the improvements apply over that whole acreage. But if you just do a small part of it, it can be hard to tease out one single irrigation block from a pump that's feeding, you know, all these other irrigation blocks as well. So that's the only issue there.
So if I pay for the labor and I pay the taxes and you pay the hardware, it looks to me like that's a cost share.
Yeah.
And yet there's an additional fee on top of that I have to pay.
Yeah.
Why?
The reason is because the DWR grant doesn't cover us for that reevaluation, to go back out in the field and verify that you've done those improvements. So since we don't get reimbursed for that, we've got to find some way to offsetting that salary. Yes, sir.
Since your program is a reimbursement program, I mean, if you think you're really doing pretty well now, and you put a new program in, maybe a new weather station and all, you find out actually you've been underwatering, not overwatering, what's the chance of that whole reimbursement being refused by DWR?
Strong. Yeah. Yeah. You know, we grapple with this because, again, we're a local organization. Can you shut that down? We grapple with this because we're a local organization. We're working on behalf of the growers. And since we're out there, we understand that a lot of times growers are being very efficient with their water application. And they may be starving their trees a little bit. And so this is one of the reasons why we always fall back on that DU value. The DU value is a critical component of trying to justify water savings because that DU value does indicate potential water savings. If you have an improved DU value, then you're potentially saving a lot of water, even if that savings isn't captured on a flow meter or a soil sensor. So the first line of defense is always to utilize that DU value improvement. If you can improve your DU value, then we can calculate a potential water savings, and that's the first thing that we're going to point to. And having said that, please be aware the DU protocol was developed by some of the brightest minds in irrigation technology. And this DU value is really the only way of getting an effective water savings. Because you can do whatever you want management-wise. You can turn the water on or off however you wish. So you could show a water reduction just by turning your water on for half the time. Meanwhile, your trees are starving, but hey, you're going to get $20,000 back. And so that goes a long way to helping those trees come back into production. So, when people say, oh, well, we just look at the water bill and that's the message to the world, there's ways of getting around that. But the DU value is the DU value because there's no way you're going to suddenly have a spectacular irrigation system without actually improving it. So the DU value is still a gold standard, even though there are funding agencies that would like to have other bits of information to go along with that, which I agree with. If you have water savings through your water bill, then that's a fantastic addition to the data. But you should never just rely just on that. You should have the improved DU value. And in some cases, people just don't have a flow meter in, so that's the only thing we can do. But I will say that generally speaking, there's always room for improvement. I think that adage holds true no matter what it is you're trying to accomplish. So I think that there could be savings that you can implement with putting in soil moisture sensors, for example. Maybe not the hardware, but I'm pretty certain that soil moisture sensors will give you a better range of your irrigation duration and your irrigation frequency. And across the board, 20% savings with people who are using Pure Sense or Hortau or even these aerometer systems. We've got all our contact information here, so please give us a call.